Once again, I welcome you all uh, for my lecture on Introduction to Smart Manufacturing and Industry and Work. All of you are hearing me, sir? Hello. Okay. Yeah, hereafter I will not. Okay, I'll go ahead. Introduction to Smart Manufacturing and Industry 4.0. I welcome to the future of manufacturing, where intelligent systems, connected devices, and data-driven decisions are revolutionizing how we products. Today, we will explore the transformative journey from traditional manufacturing to the smart, interconnected factories of Industry 4.0. So first, we will have to know what is smart manufacturing. As we all know, smart manufacturing refers to the use of advanced technologies like IoT, Internet of Things, AI, artificial intelligence, robotics, cloud computing, and big data analytics. Okay, all these techniques, by using these techniques to create intelligent, flexible, and data-driven factories. It mainly focuses on real-time monitoring of machines and processes so that we can give effective and efficient product as per the customer needs. And automation and robotics are going to use data-driven decision making so that 0% error can be achieved. Sustainability and efficiency. This is smart manufacturing, where by using advanced technologies like IoT, whatever I have told, to create intelligent and flexible data-driven factories. Well, what is 4.0? It is fourth industrial revolution. Industry 4.0 is the digital transformation of manufacturing, integrating cyber physical systems with modern technologies. The key elements of Industry 4.0 are IoT, which is the main key element, Internet of Things, where machines, device, and sensors connected for real-time data. Uh, IoT mean in IoT they are all going to be connected. Big data and analytics. Here, huge volumes of industrial data analyzed for insights. Then in Industry 4.0, another technique or another key element is artificial intelligence and machine learning, AI, EML are known. Automation and intelligent decision making is done here. And the next key element is cloud computing, where all the storage, all the data are stored and accessibility of data anywhere, wherever it is needed. Then next one is robotics and automation. This is another key element used in Industry 4.0, where smart robots are used for production tasks. Then another technique which we are mechanical people familiar, additive manufacturing, where this additive manufacturing systems it can be achieved flexible, customized productions. These are all used in Industry 4.0 to achieve higher productivity and efficiency, predictive maintenance, so that it can be achieved less downtime, better product quality and customization, and optimized supply chain, energy and cost savings, so that it can be friendly and sustainable. So, in short, briefly, we can say smart manufacturing powered by Industry 4.0 technologies transform traditional factories into smart factories. connection between all, that is machines, device, and sensors to have the real-time. Yes, please. Yes, sorry. Yeah. Okay, okay. I just I'm telling the basics. I'll be moving. I'll be moving. I'm telling the basics. What is smart manufacturing? What is industry for what purpose it is done? Like that. Just like, that is in brief. What we can tell. Smart manufacturing powered by Industry 4.0 technologies transforms traditional factories into smart factories, connected, automated, and data-driven systems. And here we are talking about Industry 4.0, how it is evolved from Industry 1.0. That we have to know before going for the details about the smart manufacturing. Actually, the industry is evolved uh, at London in the 18th century, actually from 1760 to 1840s. The era is called a first revolution of industry. Initially, at those times, there was no industry, there was no factory and all. Since the people are having more colony countries like India and other, they are having enough sources. They have brought the sources, but they have done whatever they need with the use of human power only. But later, since they have sufficient sources, they started the machineries, how to make machineries and all. They are all initially started with the steam engines, coal and iron. Okay, they have started some small companies or some machineries they have made, which are all operated by the steam engines, and by using that they have gone for some textile factories, then steam locomotives and mechanization that they have done, so that the first revolution has been taken place there. The impact of that one is some factories emerged there, and they have started some industrial economy, urbanization also taking place. So mechanization powered by water and steam engines, revolutionized by manual labor, marketing the birth modern manufacturing was done in the industry 1.0. Then later in the late 19th century, industry 2.0 is evolved, where they have used electricity, they have found the electricity at that period. They have used electricity, steam, and oil, and they have done mass productions through the assembly lines, mass productions with the assembly lines, electric power, and telecommunications advances transform industrial efficiency. Because of that, the people have got cheaper goods, faster productions, and consumer culture growth is also uh, introduced there in the Industry 2.0 revolutions. And in later 1970 to 2000, that is in 1970s, industry has evolved to next level, where it is known as Industry 3.0, the third industrial revolutions, where automations through the computers was used. They have used robotics and early data systems introduced programmable. They have introduced PLCs. Okay, and because of they have once again powered by the industry 3.0 is powered by computers, electronics, and automation and IT. I use programmable logic controllers in factories. By doing that, they have moved to next level. So, in enhanced productivity through the automation is achieved in Industry 3.0. Then the impact of this one is digital revolutions is introduced in Industry 3.0. Before that, it was not there. Then less human labor because of digital revolutions. Less human labor is used, and they uh, have global connectivity also. Then the next revolution is Industry 4.0, which is nowadays in following, especially the developed countries. They are everywhere. They are using countries developing, and poor countries going to be developed countries are somewhere they are using this one, and at many places, particularly in small scale and SMEs, they are using third revolution only. Here in Industry 4.0 revolutions, it powered by, as I told at the introduction, it is powered by IoT, Internet of Things. Is also it is use cyber physical systems to connect the machines, people, and processes. It is also used.
Hmm.
So because of using these things, sorry, real-time
Hmm.
decision making, predictive maintenance, and
Hmm.
smart factories are also evolved there. It is mainly technology centered by using the modern technologies, smart technologies. Okay, now industry 4.0 is evolved. Even now, industry 5.0 is under consideration, where it is going to be uh, human concentric, where human machine collaboration is going to be a key point or key factor is going to be considered in industry 5.0, which may come very soon. I hope you understood the evaluation of industry, how it is evolved from 1.0 to 4.0, and uh, what are all the advantages and how we are now achieving the digital transformations from the uh, traditional one. The next slide, we are going to discuss about deeply about Industry 4.0. Industry 4.0, which is also called as Fourth Industrial Revolution, is the integration of intelligent digital technologies into manufacturing and industrial process to create smart factories. It involves using cyber physical systems, the Internet of Things (IoT), big data analytics, artificial intelligence, and robotics to automate, network, and optimize production for greater efficiency, productivity, and flexibility. This transformation allows for real-time monitoring, data-driven decision making, more customized production, and highly integrated supply chain. This is what is 4.0. We move to next slide. How this 4.0, Industry 4.0 is powered. That is, what are the technologies majorly used uh, in Industry 4.0 to have the uh, smart industries. We will discuss one by one. There are many factors. I have selected some of the things, and then I will be rest. I will tell what are they by name only. For something, I will give explanation. The first one is Internet of Things. Here, sensor and devices connected to the internet, enabling real-time data collection and monitoring across manufacturing system. If we want to go for more, what is IoT? Internet of Things is what, and what it does. It connects machines, device, and sensors to collect and share data in real time. Since we are using sensor and some electronic devices, uh, every data whatever you have collected is with full 100% real data. Okay. Example, in some factories, IoT sensors monitor machine temperature, vibration, and speed to detect or these sensors will be by sensing vibrations, speed, everything to avoid the faults or what is going negatively in the machineries. Especially in Siemens company, they are using the IoT platform so that they have achieved many damages that predict by predictive maintenance they have done. They are top in their field. Then the second, still, if you want to discuss more about IoT, uh, what it is done, what is the role of IoT in Industry 4.0 generally if we discuss, they are since it is going to track the performance of the machine and how much energy is used and conditions of the machines as well the people those who are working there, uh, it is monitoring continuously. Then it is also main role of IoT in Industry 4.0 is predictive maintenance. How it is done? It, as I told earlier, uh, it detect faults before breakdowns of the machinery or what any component using the sensor data, so that since it is sensing already and before fault is taking place and communicating to the corresponding people, so that by doing the preventive or predictive maintenance the damage can be avoided. Then what is the role of the next role of IoT in industry 4.0 is automation and optimization. IoT devices coordinate protection lines with uh, minimum human interventions because of there we have used automation and optimization. So automatic robots and they can be used so that the effectiveness and the efficiency of will be higher. Then the next role of IoT in Industry 4.0 is supply chain viability. Actually, this IoT is continually tracking smartly the goods and logistics in the entire company so that it can tell where it is needed, okay, how supply chain should be, where it should be stored, how much should be produced, everything will be easily known correctly. Then the IoT's next role is workers' safety. Uh, it will be continuously monitoring uh, workers whether they are wearables or whether they are under fatigue or whether they are using safety devices properly. If they are not doing properly, it will be intimated. So workers' safety is uh, done by IoT in Industry 4.0. Some of the examples where the people or the companies are using IoT for their company to develop uh, in some smart factories, for example, Siemens. Sorry for the interruption. In Siemens, they uses IoT in their factory to produce electronic equipment where they have achieved 99.998 percentage quality rate. They are using IoT sensors to adjust speed or to monitor speed,
Slide is
temperature,
not
and
changing, sir.
uh, uh,
Sir,
I
slide
am
is not
telling, I
changing,
am
sir.
yeah, yeah. However, sir, it is about the IoT of things. Okay, the first one about that one, I am telling some more points related. It is not there in the slide. I am going to tell one by one. Okay, what are all. Then by using this IoT, predictive maintenance can be done because it is going to continuously monitor. Where in GE, General Electric Company, they are using this one. And in supply chain logistics, where it can be tracking where, for example, in DHL, they are using IoT for smart warehouse to track package and reduce errors. Similarly, energy management and water worker safety everywhere, this IoT is used. Then the second tool or second technologies which is used in powering Industry 4.0 is AI, second one, and machine learning. Uh, Actually, AI, artificial intelligence, and machine learning make factories smart, adaptive, and self-optimized by analyzing massive industrial data. Here, the systems that analyze data predict outcomes and optimize the processes and autonomously without human interventions. And what are the general roles of AI and ML in Industry 4.0? I will briefly explain. Again, this AI and ML is mainly used for predictive maintenance because this machine learning algorithms analyze sensors uh, data to predict machine failures. Generally, this will be finding the in advance machine failures so that predictive maintenance can be done. As well, mainly used for quality control. This AI machine learning is used for quality control. That is AI powered computer vision detects defects faster than the humans. Okay, this AI machine learning this will be detects very fastly where the defect is there so that the quality control will be successful there. Also, the role of AI in machine learning, AI and machine learning in Industry 4.0 is process optimization as well supply chain and inventory management, robotics and automation, and smart decision making because here everywhere it is giving they are analyzing or receiving and sharing the real time data for all everywhere energy saving protection planning and safety improvement so that the decision making can be done smart decision making. Okay, then the next parameter or next tool or next technology which is powering the Industry 4.0 is big data analysis. Here, by processing massive data seems to uncover insights and drive intelligent decision making in real time. Okay. I will discuss something about this one a little deeply. What is actually big data industry? Actually, Industry 4.0 generates massive data from it will be collects massive data from the another things what is connected with them that like IoT devices, sensor, machine, and production line through which there are lots of data, massive data is collected, real-time data. This data is higher in volume with high speed, high velocity, and this big data analytics helps uh, process, analyze, and extract insights to improve the efficiency, decision making, and innovations. Okay, so this technique, big data analytics, here it is actually what is done here is this will be what it will be doing is it will be collecting real-time data between machineries and processes. Okay, all the data are collected and stored somewhere, and they are going to be analyzed and to improve efficiency, decision making, and innovation. Then the next core technology which is used in Industry 4.0 revolutions is robotics and automations. As we know, advanced variety of robots nowadays are used in industries. Advanced robots performing complex tasks with precision uh, and flexibility, adapting to change the protections. Okay. Uh, if we want to discuss more about this one, robotics and automation, actually what it will be doing is Industry 4.0 focuses on smart factories where these technologies are interconnected, enabling real data-driven and decision making. Okay. The key features of these robotics and automations in AI of Industry 4.0 is somewhere they are using autonomous robots. These take a kind of robot that can make decisions based on the sensor data and AI algorithms through which they are getting data, and they will be modifying themselves and doing the things by its own. Where collaborative robots nowadays majorly used in this modern or smart industry manufacturing system. It is designed to work safely alongside the humans, and it will be taking care of the safety of the workers also to enhance the productivity as well as the safety. And the key features of these robotics and automations, it is flexible, should be flexible automations. So according to the changes are there in the manufacturing system, it will be flexible and adaptable. And as we discussed for all other technologies, here also this is mainly useful for predictive maintenance. Using sensors and AI, it is predicting failures in advance so that reducing the downtime can be reduced, the idle time can be reduced. Then integration of with IoT generally, the robots and automation systems collect and share data to optimize protection system. Some of the examples where this robotics and automations are used in industry 4.0, where automotive industry, where as we know, robotic arms assembling cars, robotic arms assembling cars with precision and consistency. Okay, whatever the distance should be moved, it can be moved very precisely. And in electronics manufacturing industry also, they are using this robotics and automation, especially for pick and place robots. They are used for keeping or for having the circuit board manufacturing. Okay, and it is also used logistic and warehousing. They are using in logistic and warehousing. For example, AGV vehicles we know, as we know, for transporting goods, they are using these robotic and automations. And in food industry also, they are used. Um, for example, packaging, sorting, and quality inspection industries also, they are using robotics and automations to have effective work in nature. And in healthcare sector also, robotics and automations used, uh, like the surgical robots, automatic lab testing machines they are all using. The, the next tool or next technology used in powering industry 4.0 is cloud and cyber physical systems. That cloud means, as we know, their data are going to be collected by using the cyber physical system. Cyber means some using algorithm and all, where physical means machine process as well as humans. Okay, people those who are related with that. Okay, their real-time data were collected by using the sensor or other any AI, IoT techniques or AI machine learning. Okay, this is done in cyber physical systems, and these data are stored somewhere. It is known as a cloud, and by combining them, both are analyzed and whatever things needed to improve, it is going to be done. If we tell how cloud and CPS work together, actually CPS means cyber physical systems. CPS generates massive amounts of data from sensor and machines, as I told, and where cloud computing stores and analyzes this data in real time. They together they are very much useful for smart decision making. because in cloud computing the data are stored, and where they are doing analysis also, what are the data, based on that wherever it is needed improvement, there it will be done, and what are the things to be done and what are the things not to be done, everything can be analyzed and giving very accurately. So together they CPS as well as cloud computing together they are enabling smart decision making. uh, Wherever it is they needed to take decision, it can be taken smartly, and small remote management of protection and supply chain management also can be done effectively. And actually, we have discussed only only five technologies in deeply, and apart from that, there are some more technologies also used. As I said at the beginning, rapid prototypes also can be used. If use this one, uh, instead of going for very that is by using 3D printing, we can have a small prototype and then we can do testing everything in that, so that cost is also can be effectively used. Okay, and cyber security is another technique which is used in Industry 4.4, where they are securing our data, everything, protects industrial networks, IoT devices, everything. And virtual reality and human reality, another technique which is technology which is also used there. So these are the some of the techniques are used in Industry 4.0. Then I hope you understood what are the technologies majorly used in Industry 4.0 in smart manufacturing system. Then I will move to next slide. What are the key features of Industry 4.0? Uh, the first one is automation. Since self-operating machines are used, they reduce manual interventions and human errors while maintaining quality standards. Okay, since automation is one of the features used in Industry 4.0, self, as we discussed, human interventions is reduced. Uh, then the second key features of Industry 4.0 is interconnectivity. Devices and systems uh, communicate across the entire production and supply chain, creating a seamless workflow. So here everything is connected. Machines, devices, sensors, and people are connected through Internet of Things, uh, so that they can achieve their productivity higher. Then the real-time data, uh, because continuously monitoring the machines and processes. Uh, Here, continuously all the data, real data, are stored or collected by using this IoT and other techniques, uh, so that instant decision making is possible. Okay, and responsiveness to changing the conditions are anomalies. It is also possible here. Then the next one is a rapid flexibility. And since we are using these modernist techniques in Industry 4.0, whatever may be the flexibility is needed can be done very easy. Then we'll move to next slide. The smart factory. It is the heart of the Industry 4.1. The smart factories represents the pinnacle of Industry 4.0 implementation, equipped with embedded sensors, robotics, and AI-powered analytics that transform traditional manufacturing process. Okay, what it is going to be done? Enables predictive maintenance, reducing downtime. Downtime, the ideal time is going to be reduced because of it is anticipating equipment failures. Okay, since then and there the data are collected. If any worn nodes or any looseness else of bottlenecks, for example, I am telling, or any mistakes is there in the parts or processes, it will be immediately monitored and communicated to the people so that the failures can be avoided. Then it facilitates self-optimization of manufacturing process for higher yield and quality. Since real-time data are collected, okay, these technologies they themselves analyze and optimize what are all the process, optimize the process by using the process what are all to be done according to that optimized techniques or system processes it is done to achieve the higher yield and quality. Then next AI powered visual inspections replaces manual quality checks. If you in earlier industry 3.0 where the quality checking everything is done manually. Whereas here, this quality checking in 4.0, it is going to be done with the AI-powered these tools, okay? Digital tools they are used so that quality checking will be done on time and very quickly and very accurately so that can be saved the cost. Then the next one is real-time production adjustments uh, real-time production adjustments based on demand fluctuations. Okay, uh, uh, as I said earlier, as per the demand fluctuations, uh, these all digitalized tools are having their data then and there. So it will be monitoring and checking, analyzing what are the demand and how it is going to be demand fluctuations. Based on that, the productions are going to be done. Uh, Also, some other key features of the smart factories are uh, smart real-time monitoring control and connectivity since all the parts are going to be connected so that the real-time data can be collected, especially Siemens factory. Siemens in their factory they are monitor machine performance instantly to reduce the energy usages. As well, predictive maintenance can be done as afterward, and flexibility customization, human machine collaboration, sustainability, and efficiency. These are all the uh, techniques or some key points are used there. Why it is called heart of Industry 4.0? The smart factories is called a heart of Industry 4.0 because of the following reasons. Generally, since here they are bringing all core technologies, IoT, big data, AI, robotics, cloud, AR, VR, and 3D printing, some others, what we have discussed here, there. It is bringing all technologies at once. Uh, then it transforms traditional manufacturing into intelligent and adaptive ecosystem and it drives high productivity, quality, cost saving, and sustainability. Because of that only, because of these main reasons, because of these reasons, this smart factory is the known as heart of Industry 4.0. Then we'll move to next slide where uh, we will be discussing about why smart manufacturing systems matters today. Because smart manufacturing is are very important nowadays because of the global competition. Because it demands is very faster. So based on the demand, we need to supply the products also. Uh, and moreover, we are supplying globally. So this smart manufacturing system is very very important. So it demands faster, more efficient, and customizable production to meet evolving customer expectations and market prices. Then, why smart manufacturing matters today? Then, second reason is proven results. Okay? Smart manufacturing improves productivity, by up to 20% and reduces the defects by 50% according to comprehensive IBM studies. From this IBM study, this data is collected. So since the productivity is increased by 20% and defects are reduced to half, so that it is necessary nowadays a smart manufacturing system. Then uh, sustainability focus, since here the energy use is very optimized and wastage is also reduced, so that it will be eco-friendly and sustainable. So it is very important to use nowadays. Then some more reasons why these smart industries are needed nowadays that we will discuss. It increased productivity and efficiency, as I told earlier in another point. Automation and real-time data reduce downtime and speed up the production. Some the examples I can give: Tesla factories use AI and robotics to assemble cars faster than the traditional plant. Obviously, if you use automation, definitely the productivity will be higher. And it is used because of the cost reduction is higher. Predictive maintenance lowers repair cost because as we discussed so many times here, because of these tools used, we can predict the faults in advance, so that by using the predictive maintenance, repairs can be done very early, so that we can avoid unexpected breakdowns. So the repair cost uh, saving is done highly. In example, from the sources, we know that in GE, they saves million by predicting turbine failure yearly by using this smart technologies. Then the next factor is customization and consumers demand. Even told customers demand personalized products at mass production speed. Uh, in traditional manufacturing system, we have batch production and mass productions like that. But whereas if we come to here in Industry 4.0, the smart product manufacturing system, even customized products can be done at a speed of mass production speed. For example, Nike offers customized shoes using the smart manufacturing system at the same speed. Okay, even if they specifically need any design, they are giving by using these technologies. Then global competitions, I have told already, since day by day the demands are increased globally. This smart manufacturing systems will be used to overcome that one. Then sustainability and green manufacturing system, as I told earlier. Then supply chain resilience, and since they are using real-time tracking and analytics, they improve the supply chain transparency. Example, the Walmart use this IoT and other techniques to ensure food traceability and reduce delays. Uh, uh, Now we have discussed why smart manufacturing systems are important in today. Then in the next slide, we'll be discussing Industries 4.0's impact on the global economy. It boosts in productivity and growth. Uh, Smart factories enable faster, uh, so that more efficient production. It impact higher GDP contribution from the manufacturing sector. Example data is collected from there. McKinsey estimate company estimate Industry 4.0 would add $3.7 trillion annually to the global economy by 2025. Okay, so since productivity and GDP is higher because of these modern systems. Then job transformation. Routine repetitive jobs may decline due to automation. And there will be, since new technologies are used, many job opportunities also there because of this one. And new opportunities arises in AI, robotics, IoT, data science, and cyber security. Example: World Economic Forum projects 97 million new jobs by 2025 in technical driven roles. Then global trade and supply chain impact on the global economy. Real-time monitoring strengthens supply chain resilience. Uh, Countries with the smart factories gain competitive advantage in export. For example, in Walmart, they use blockchain and IoT to track the shipments globally. Then, 1 minute, sir, after water. Then, the impact of Industry 4.0 gives innovation and new business models. Okay. For example, one certifications a new technique where products plus service combined is called growth of certifications as well. A digital platform nowadays marketing is then even digital platform and like that. Uh, New business models are used and on-demand production is also done. Then example, Royce Rolls-Royce sells power by hour. This is a technique where the aircraft they are not going to own the maintenance or own engines. Simply, they will be what it is renting like that. Okay, they will be renting the engines hourly basis. How many hours it is they are using? For that they have to pay. So that this Rolls Royce they are taking care of the maintenance and uh, repairing everything of the engines. Okay, uh, which will be benefited both sides. Okay, aircraft people they will not be they no need to be worrying about the engines. It is taken care by the Royal. This is known as power by the hour. Like in olden days, in our olden days, we used to take the cycles for rent. It was like that. Okay, whatever we are using for that, we need to pay. The rest they will be taking care. Okay. Then industries 4.0's impact on the global economy, sustainability and green economy. Real-time monitoring strengthens supply chain resilience. Countries with the smart factories gain competitive advantages in export. Example, Walmart, I think we have already discussed about it. Then global inequality and digital devices. Here, developed countries benefit faster this industry 4.0 because they have advanced infrastructures, whereas developing and underdevelopment countries nations risk lagging uh, behind without strong digital adoption. And the impact is need for global collaboration and technology transfer. Uh, the next, what are all the challenges and opportunities are there uh, in this smart manufacturing system? The opportunities in smart manufacturing system are enhanced efficiency and productivity. As we discussed so many times, because of this digital platform is used, combining with the manufacturing system, it is enhancing the efficiency and productivity. Okay. Then data-driven and this one is nothing but since these all those AI, IoT, and all those ML, all those techniques are continuously monitoring and collecting the data, real-time data, so that a decision making is perfect. Okay, immediately can be taken without any mistake, and flexible and customized production, as we have uh, told previously. Like it is very adaptable for the flexible manufacturing system. That is, wherever it is needed, uh, any demand changes. Okay, wherever it is needed any changes, it can be done easily. It is not necessary to go for new machines and new techniques and all. And whatever the customized protections can be manufactured at the speed of mass production by using the smart manufacturing systems. Another opportunities or advantage of using this smart manufacturing system is cost reductions. Okay, since as we told, fault findings are done as well as no downtime. Downtime is very less because supply chain is also going to be done very effectively, so that the cost reduction overall unnecessary costs are reduced by using this technology. And parallelly, what are the challenges are done? Well, what are the challenges whenever we are going for Industry 4.0? The smart manufacturing system is high initial investment because we are using uh, this AI, IoT, this digital devices. It is actually initial cost very costly. Advanced robotics, cloud infrastructure, they are very costly. Companies like small and medium enterprises, they can offer this one. Okay, so high initial investment is one of the very big challenges for many companies. Then cyber security risks. Sometimes the data can be what is stolen, or some cyber attacks can be taking place. Nowadays, it is reduced very less, but even then it may be possible. Uh, and protecting sensitivity protections and design data is crucial. Then the next one is next challenge is to use this smart manufacturing system is uh, workforce skills gap, uh, which means it needs engineers and operators skilled in AI, uh, all other techniques, what robotics, data analytics. So there may be some skills gap, and so it is needed reskilling and upskilling the existing staff essential to overcome this one, or otherwise it is necessary to recruit new people. Uh, but since we are uh, improving our manufacturing systems to one smart manufacturing system, we cannot completely throw all our employees. So it is needed to give some special techniques to them. Then the next one is integration complexity, which is legacy systems may not easily integrate with the new digital technologies, uh, which is also and adapting or connecting machine with digital things also will be having some complex. As well, some more things are there. Some standardization issues are there. Lack of universal protocols for IoT, other things, and change management. If managements are changed, then everything will be the challenges to make smart manufacturing effective. Okay, these are all the challenges briefly I have explained, and opportunities when we are using smart, when we are going for smart manufacturing in Industry 4.0. Uh, and with that, I stop this lecture. If you have any questions, you are welcome to clarify. Okay, thank you. Okay.
Sir, Balaji sir.
Yes, sir. Please, sir.
Yeah, yeah, sir, that's a nice presentation. I have one doubt, sir. So, what is the
Yes.
role of the simulations before going for the actual run in the for smart factory? If you see, the cost of budgeting of investing in the smart factory is high. So, before that, what will be the role of the simulations that are very much that nearest to the realistic? How they will enhance, or any platforms are there to observe that thing?
Sorry, can you repeat, sir? I am not hearing you properly. Sorry.
So regarding smart factory, if I want to convert a existing conventional factory into a smart factory, are there any supporting simulation platforms to look into that thing, feasibility of the uh, adoption to the smart nature?
Actually, it is possible, sir. From the present one, okay, traditional manufacturing systems too, if you want to go for the smart manufacturing system,
Yes,
uh,
sir.
it is completely we need to look for this digital things, okay, like these are all AI, ML, IoT, these things are to be implemented there, which will be costing very high initially. Uh, Actually, totally it is going to be different, I think.
Okay, sir. Thank you, sir.
Okay. 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 Thank you. Thank you, sir. Thank you so much.
Yes, sir. Thank you, sir. Thank you.
Thank you.
Yes, sir. Sir, yes, sir. I think we can close the session, sir. People are leaving already. Mm,
No, sir, no.
okay,
Thank you very
okay. Yes, sir. You can close the session, sir.
Okay.